Nana's Beauty Science Salon, Day 2A, the Nail Lamp Electricity Room. The next morning, Nana opened the second door in the salon. The sign said, "The Nail Lamp Electricity Room." Inside, everything glowed. There was a UV nail lamp, a bright makeup mirror, a hair dryer, a hair straightener, a phone charger, and a wall full of circuit diagrams. Tinos looked nervous. He said, "Electricity is worse than sound." Nana said, "No, electricity is just a salon with moving charges." Debbie sat in the nail chair. She said, "Good. Explain it before you plug anything in." Nana placed her hand under the UV nail lamp. Nothing happened. Tino said, "It is broken." Nana shook her head. She said, "No, the circuit is open." She clicked the switch. The lamp turned on. Nana said, "Now the circuit is closed. Electric current can only flow in a complete circuit." Tino said, "So open means broken path, closed means complete path." Nana said, "Exactly." She pointed to the wires. Electric current is the flow of charged particles. In metal wires, the moving charged particles are electrons. Tino said, "So current is the flow." Nana said, "Yes, current is measured in amperes." She wrote on the mirror, "Current means flowing charge. Current is measured in amperes." Then Nana picked up a bottle of nail polish. She gently pushed it across the table. Nana said, "Now imagine voltage as the push." Tino said, "Voltage pushes the electrons?" Nana said, "Yes, voltage gives energy to the charges and pushes them around the circuit." She pointed to the power supply. "Voltage is measured in volts." Tinos repeated, "Current is flow, voltage is push." Nana smiled. "Good. Now we need resistance." She took out a small brush and pulled it through tangled hair from a practice wig. The brush moved slowly. Nana said, "This is like resistance. Resistance opposes movement." Then she brushed smooth hair. The brush moved easily. Nana said, "Low resistance means current flows more easily. High resistance means current flows less easily." Tino said, "So resistance slows the current." Nana said, "Yes, resistance is measured in ohms." She wrote 3 lines on the mirror. Voltage is the push, current is the flow, resistance slows the flow. Debbie said, "That is actually easy." Nana said, "Now we connect them with Ohm's law." She drew a heart on the mirror and wrote inside it, "Voltage equals current times resistance." Tino said, "That sounds like a formula." Nana said, "It is. Ohm's law is one of the most important electricity rules." She said it slowly. "Voltage equals current times resistance." "If we know 2 of them, we can find the third." Tinos asked, "How?" Nana said, "If you need voltage, multiply current by resistance. If you need current, divide voltage by resistance. If you need resistance, divide voltage by current." Tinos looked at the UV lamp. Nana gave him an example. "If a circuit has a voltage of 12 volts and a resistance of 4 ohms, what is the current?" Tinos thought. He said, "Current equals voltage divided by resistance. 12 divided by 4 is 3. So the current is 3 amperes. Nana clapped. "Correct." Then she pointed to different materials on the table, a copper wire, a plastic comb, a tungsten bulb filament. Nana said, "Different materials have different resistance. Copper has low resistance, so it is used for wires. Plastic has high resistance, so it is used for insulation. Tungsten has high resistance and a very high melting point, so it can glow in a light bulb." Tino said, "So we choose materials depending on what we need them to do." Nana said, "Exactly. Electricity is not magic. It is controlled movement." At the end of the room, Nana wrote the memory script. A circuit must be closed for current to flow. An open circuit has a gap. A closed circuit has a complete path. Current is the flow of charged particles. In metal wires, the charged particles are electrons. Current is measured in amperes. Voltage is the push. Voltage is measured in volts. Resistance opposes current. Resistance is measured in ohms. More resistance means less current if voltage stays the same. Ohm's law says voltage equals current times resistance. Tinos read the last line again. Voltage equals current times resistance. Nana said, Perfect. Next, we use this in series and parallel circuits.